For today's video, we're going to be working with live electricity, so unless you're an electrician, don't try this at home. We're actually going to put an amp probe on the wiring and see how many amps it's drawing while in usage. Then we're going to turn it off, clean the entire coil all the way around, start it up again, let it run long enough to dry out and get all the way up to pressure, and then recheck the amp draw and see if it really is worth it from an electricity standpoint, cleaning off the coil. So the idea behind this, and why this should work, is that for refrigerant, pressure and temperature are very closely tied together. So your compressor pressurizes the refrigerant, which then makes it hot, and then the fan sucks air over top of it, which cools it down. So the better your airflow is over top of the coil, the more heat that's let go. The more heat that's let go, the lower the pressure goes. The lower the pressure goes, the easier it is on your compressor. So you should be drawing less amps with a clean coil than a dirty coil. All right, let's get right into it.
Alright, so what I wanted to show you here is the compressor has been running all day. This is right when I got out there and took the cover off. I didn't shut it down or anything like that. And as you can see, it is 91 degrees is what that thermometer says. My phone said 93, so you know, it was hot. So the compressor's working really hard today, and it's varying a little bit, but it's going back and forth between about 16.46 and 16.55, so it's fluctuating a little bit right in there, which is probably the meter itself, not the compressor varying. And what I'm showing you here with the thermometer is 105 degrees. Now that's the temperature coming out of the coil after it's gone through the coil and it's had everything, all the air has been blowing around it and cooling it down. So that's what's going back to the actual valve and being sent to the unit inside, 105 degrees. And spraying it off with the hose right there, you can see how much difference it makes in the amp draw just by cooling down that coil. So the better airflow, the cleaner the coil, the more the temperature drops, the more the temperature drops, the more the pressure drops, which saves you electricity. And you see it's all the way down to 15.4 right now. So it does get down a whole lot, and that's why compressors are much more efficient, or heat pumps should I say. A heat pump is much more efficient when it's temperate outside. So if it was a 75 degree day, it would be a lot more efficient than if it's a 100-degree day. So I've got the power disconnected now, and I just wanted to show you the difference. See, I just cleaned that. You see how it's relatively clean and silver. I just took this panel off, and as you can see, that is extremely thick and caked on there. So I'm gonna finish cleaning it off. See, I did this side already. We've got this side and then the back side to do. And then we'll hook it all up, start it up, let it run again. Let it run long enough, like 15 or 20 minutes, to make sure it's completely dry so we're not getting any false measurements from the water on the coils. And then we'll be able to see how much of an amp difference it actually makes. So stay tuned. I've got everything cleaned off. All four sides are now clean. The coil has had time to dry off. The unit's been running for about 25 or 30 minutes, and the amps are now stable. It's bouncing back and forth between 16.15 and 16.25, so about 0.3 amps is how much less electricity this is using. That works out to around a 2% increase in efficiency, so not a huge difference, but there definitely is a difference. If you look at this, you can see 98 degrees now is where the refrigerant is leaving the condenser. Before we cleaned it, it was 105, and also it's 2 degrees warmer outside, so it definitely does make a difference. Every bit of extra airflow you can get to cool that coil down does translate into better electrical efficiency and a lot easier time for the compressor keeping pressure. And as you can see, it's all the way down to 16.13 now.
Alright, that's the video for today. The difference ended up being 0.3 amps, and at 220 volts that works out to about 66 watts. So definitely a little bit of an improvement cleaning the coil, but the main thing is your compressor is going to last a lot longer because it is running at less amps and less power, so it doesn't wear out as fast. I did also notice that when the entire coil was wet, the amps went all the way down into 13. So that brings up another question and an idea for a video. I have a little creek from the backyard, and I'm just wondering if I were to have a little tiny pump that only took a ½ amp or so, and I were to pump water up and pour it all over the coil and have it run continuously, how low could I get the amperage? So stay tuned for that one.